Hello all, welcome to my video lecture series number 3, and this is the continuation of the last class. And the last and the previous before class we have seen about the term and concepts of interprocess communication and how the message is passed and how the shared memory has been used and etc. And in this class we'll just go with something called as implementation of interprocess communication, that is IPC, using some terminal components. So the mechanism for processes to communicate and synchronize their actions is said to be the interprocess communication's main aspect. And regarding the message system, processes communicate with each other without restoring to shared variables. Coming to the IPC facility, it provides two operations, that is sending the message and receiving the message. And if P and Q are assumed to be the processes which maybe communicate with each other, if P and Q wish to communicate with each other, they need to establish a communication link between them and exchange messages via send and receive option. The implementation of communication link can be done by either physical mode or logical mode. Coming to the physical mode, we can use the term called as shared memory space or hardware bus. And next, coming to the logical purpose, we can use the logical properties for IPC. So how are links established? Can link be associated with more than two processes? How many links can there be between every pair of communicating processes? What is the capacity of a link? Is the size of a message that the link can accommodate fixed or variables? And is a link unidirectional or bidirectional? These are some snippets from the last class, and we can see it in detail in this class. That is, in this aspect of communication, we'll just start with something called as direct communication. The process of the processes must name each other explicitly. That is, one is sending messages and receiving messages. Coming to the sending messages, the P1 message can send message to process P, and the receiving messages and receives the message from the process Q. And regarding the properties of communication link, links are established automatically. A link is associated with exactly one pair of communicating processes. Between each pair, there exists exactly one link. The link may be unidirectional, but it is usually in terms of bilateral or bicommunication. The indirect communication, messages are directed and received from mailboxes, and it is sometimes referred as ports. Each mailbox has unique ID, and the processes can communicate only if they share a mailbox. And coming to the properties of a communication link, the link established only if the process share a common mailbox. A link may be associated with many processes, but considering some pairs, each pair of processes may share several communication links. The link may be unidirectional or bidirectional. Operations can be termed or consoled in these terms: create a new mailbox, send and receive mailboxes through the sending and receiving the messages through mailbox, and of course we are terminating the mailbox, such as destroying the mailbox. The primitives are defined as send, that is a message, send a message to mailbox A and receive a message from the mailbox A. So let's not get confused with the mailbox aspects, but mailbox is for sharing the messages. That's what we have to understand from it. So the term called, let me zoom it for you, P1, P2, P3 share something called as a mailbox that is named as A. P1 sends a message to P2 and P3, and it receives. Who gets the message? That's the aspect. Coming to the solutions, allow a link to be associated with at most two processes. Allow only one process at a time to execute a receive operation, and allow the system to select arbitrarily the receiver. Sender is notified who the receiver was and as. So coming to the synchronization, message passing may be either blocking or non-blocking. Blocking is considered as synchronous, non-blocking is considered as asynchronous. Send and receive primitives may be either blocking or non-blocking. Coming to the buffering aspects, the queue of messages attached to the link implemented in one or three ways, that is zero capacity, bounded capacity and unbounded capacity. Coming to the zero capacity, there are zero messages, that is, sender must wait for a receiver and in a rendezvous concept. And coming to the bounded capacity, it does have a finite length of, coming to messages, it can accommodate finite length of n messages to be specific, and sender must wait until it is full, that is, wait if the link is full. Unbounded capacity means it is stated as infinite length and receiver sends and receives at its own time. And thank you for listening to this. Thank you.